Hello my dear friends, welcome back to learning mathematics. Let's continue with exercise 13.2. For this I've already discussed in the other videos and all, but still then for this particular exercise we have some few problems, not too many problems. And to continue with this exercise we will be needing some of the theorems from limits. They are exponential, that is limiting value of e power x minus 1 divided by x as x tends to 0 is equal to 1. Then we will also be coming across this limiting value of the function log of 1 plus x to the base e divided by x is equal to 1, and also of course the trigonometric limits, that is limiting value of the function sine x divided by x as x tends to 0 is also 1. So this will be some of the formulas, theorems that we will be requiring in this exercise. Okay. Alright, moving ahead with the question then. The first question is the function is e power 4x minus 1 divided by x. Almost similar, if you can see, isn't it? Right. So now if I just, here the value of x is like 4x. So if I can just multiply and divide by 4x, then the term becomes same. And as we know that as x tends to 0, 4x also tends to 0. So we'll just bring in this missing value, that is e power 4x minus 1. Remember, these are just models only, isn't it? So I will multiply and divide. So if I multiply, I'll have to divide also. So now just making a small change, that is 4x tends to 0 if you wish. E power 4x minus 1 or 4x into 4. 4 is a constant, so okay, I'll just keep it outside. Alright, because we know that as x approaches 0, definitely 4 times of x also will approach 0. So this value, as we know from here, it is 1. So 1 into 4, how much will it be? It is going to be 4. Okay, now. Alright, moving ahead to question number 2, that is limiting value, limit of the function e power 2 plus x minus e square divided by x. Okay, so this one can be written as limit x tends to 0 e power 2 e power x, from law of indices, that is a power m plus n, can be written as a power m into a power n minus e square divided by x. I'll just continue here. So that is limit as x tends to 0, e square I can take common, so e power x minus 1 divided by x. Now e square is a constant, taking it outside. Limit as x tends to 0 e power x minus 1 divided by x, so that is e square. This is the direct theorem 1, so e square into 1 e square. Okay, okay, moving on to question number 3. Okay, now question number 3 is limit of the function e power x minus e power 5 divided by x minus 5 as x tends to 5. We know the formulas, isn't it? The theorem, that is e power x minus 1 divided by x is equal to 1. So what we will do is, let's do something. Let's x minus 5 is equal to, let's say, y. So then what happens? Then limit x minus y becomes 5, because just trying to arrange that to our formula theorem, e power x minus 1 by x. Now we know that, see, as x tends to 5, what is going to happen to y? As x tends to 5, that means as it is very, 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 very close to 5, 5 minus 5 approximately, that is also going to be 0. So limit as y tends to 0. E power x. Now this, if we can replace, then we can write this as x can be written as y plus 5. So y plus 5 minus e power 5. So just like now the previous question, e power 5 e power y minus e power 5 divided by y. So limit as y tends to 0, e power 5 taking common, e power y minus 1 divided by y. So e power 5 taking it outside. Limit as y tends to 0, e power y minus 1 divided by y. So that is e power 5 into 1. That is e power 5. Okay, to na. Right, chalo, let's go to number 4. Limit as x tends to 0, the function e power sine x minus 1 by x. So what I'll do here is, remember this formula, x term should be same. So what is missing here as x tends to 0? Because we know one thing for sure, that is as x tends to 0, what happens? Sine x also tends to 0, isn't it? Because as x approaches 0, like it's like, for example, let's just assume that it is 0. Of course it's not 0, but like very close to 0. That's almost 0. Sine 0 is how much? Approximate, like sine very small. Sine 0 is 0. So this is also approaching 0 only. So that's why we can do that. We can use the model sine x minus 1 divided by, what I'm going to do is I will multiply and divide by sine x. Of course this x is there, let's not forget it. So then this will be limiting value of e power sine x minus 1 by sine x, because we know that as x tends to 0, sine x also tends to 0. And then again continuing, limit as x tends to 0 for this function sine x by x. How much is this? 1. How much is this? 1. Answer is how much? 1. Because we know that limiting value for sine x by x as x tends to 0 is also 1. Okay na? Okay, chalo, number 5. Done. Pause the video, write down. Okay. Yeah. Zalo. Number 5. That is limit x tends to 3 e power x minus e power 3. Remember this question? Similar question we did, no? Yes, 3. Now see, similar, that's why I'm writing 5. I think question number 3, isn't it? So let's not waste much time. Let's do it directly. Limit x, yeah. So limit e power, this will be y. Again, see, I was so into that question number 3 that I'm continuously writing. As x tends to 3, y tends to 0. So e power y plus 3 minus e power 3 divided by y as y tends to 0. So limit y tends to 0. Actually, these questions are still not enough. The more you do, the merrier you are, the more knowledgeable you become. There's only one shortcut to mathematics, that is no shortcut. Do more, and more. So our idea is always to transform that to one of those theorems so that we can compare and use those theorems and solve. So that is what we always try to do. Okay, you get a question, you are given a set of theorems, right? So our job is to convert those or transform those questions almost with respect to those theorems so that we can use those theorems as models. That's what we are trying to do every time. That's why we simplify, do all these steps and all. Acha, here what shall we do? Acha. I'll multiply and divide by 1 plus cos x, maybe. Let's see. So this is a plus b into a minus b, that is a square minus b square. I'll continue here just to save space and time and to save paper and to save the environment. Now time to arrange. You remember the first three theorems? We basically going to stick to this, especially this two, 1 and a 2. Chalo. Okay, anyway, let's just arrange e power x minus 1 divided by square. So I'll need a square if I have to use that formula, that is limit for sine x by x as x tends to 0. So these terms have to be same. So if this is square, so I'll need a square. So that means I'll have to multiply and divide by x square. This will remain the same, 1 plus cos x. So now 1x here, 1x here cancelled. So that will be limit as x tends to 0. Time to arrange e power x minus 1, this x now into, anyway, we will write one more step later on. 1 plus cos x into niche mein sine x by x. We can write this as whole square, no problem, right? Okay. All right. Now, again, okay. So let's arrange this now. Okay, I'll just do it here if you don't mind. So that will be limit as x tends to 0 e power x minus 1 by x into limit as x tends to 0 1 plus cos x divided by 1 by, we know this with from basic operations of limits now, sine x by x whole square. All right, so this is how much? 1 into, how much is this? We don't have any formulas for this, but here you can just put the value of x equal to 0, so you can just use the limit. So 1 plus cos 0 is how much? 1 plus cos 0, nobody knows, right? And this is 1 by 1 square. So 1 into 1 plus cos 0 is 1 into 1. So that's going to be 1 into 2 into 1. Answer is 2. Chalo. 7. Okay, so this is the basic formula. What was the formula? That is limit as x tends to 0 log of 1 plus x divided by x to the base e is 1. So almost same, just 2x is there, no problem. That is limit x tends to 0 log of 1 plus 2x to the base e x. I'll multiply and divide by 2, so the model becomes same. And we know that as x tends to 0, 2 times of x also will tend to 0. So if you want to keep everything proper. So 2 I'll take outside. Limit 2x tends to 0 log of e 1 plus 2x divided by 2x. So this one already given 1. So the answer is 1. Alright, fine then. Let's move on to the last question. I mean, answer is 2, not 1. Kya 1? 2. Question number 8. Almost similar to another question, that is limit as x tends to 0. Time to arrange. Log of 1 plus x cube. Now we see again, as x tends to 0, x cube also will be actually more smaller now, 0, isn't it? Because as x is very, very small, x cube will be very, 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 very small again, isn't it? Because for example, like 0.1. Now 0.1 whole cube will be like 0.001. Just imagine. So it's going to be much more smaller again. So as x tends to 0, definitely x cube is going very, very close to 0. So that won't make a difference. So I'll introduce x cube. All right, and then we have here now, okay, anyway, let's just do for this. So it serves both the purposes now, you see, just bringing in 1x cube, multiplying and dividing by x cube, because it serves the purpose for this also, it serves the purpose for this term also. Just imagine, isn't it? That means I'm not doing anything, I'm just multiplying and dividing by x cube in the denominator, because it doesn't make any difference to the function, because I can just cancel this. No, it's a cancel, so you still have the function left intact, isn't it? Yeah. But once you do that, you see it serves a lot of purpose, because now time to arrange, that is limit as x tends to 0 log of 1 plus x cube. Let's save all the basic details, okay, sin x by x whole cube. So then it becomes limit as x tends to 0 log of 1 plus x cube divided by x cube into 1 by limit as x tends to 0 sin x by x whole cube. So I'll just write it here. This is how much? Term same, x cube tends to 0. This is 1, this is also 1. So answer is how much? Okay, 1. Bus. So you just have to do that. So it's simple, but yes, do practice more and more questions. That will give you more varieties, more ideas, more concepts. Alright, fine then. I hope you've liked this video. I'll see you with the next exercise. That is, we move on to now derivatives in the next exercise. Okay, fine then. Study well. All the best. Bye-bye.